Hello everyone, hopefully you're doing well. In this video, we're going to continue with chapter 5, exponents, polynomials, and polynomial functions. We're going to focus a little bit more on factoring, but this times we will do factoring by special products. Remember in the previous sections, if you miss any of these videos, I would strongly advise you to go back and watch videos I cover where I covered exponent and scientific notation, work with exponent and scientific notation, polynomials and polynomial functions, multiplying polynomials, the greatest common factor, and factoring by grouping, factoring trinomials. So in this section 7.5, we would talk about factoring by special products. Our goal is to factor a perfect square trinomial, so factor the difference of two squares and factor the sum or difference of two cubes. In the previous sections, as we said, we considered a variety of ways to factor trinomials of the form AX. Remember, we went over multiple techniques on how to factor trinomials in the form AX plus BX plus C, where the coefficient of x squared is 1, and some other examples where the coefficient of x squared, which means a, is not equal to 1. So we went on using a variety of techniques on how to do it. A trinomial, that is, in this one, we're going to mostly focus on trinomials, factoring by special products. Here we said that a perfect square trinomials can be factored quickly if you reorganize the trinomial as a perfect square. So a trinomial is a perfect square trinomial if it can be written so that its first term is the square of some quantity A. Okay, its last term is the square of some quantity b, and its middle term is twice the product of the quantities a and b. So, if you want to define this one, you would say a trinomial that is the square of a binomial is called a perfect square. For example, if you have anything in that form, let's say if I have x squared plus 2xy plus y squared. If I have something like that, what happen if I have something like that? What's gonna happen is we can, if we have something like that, all we can do is to use the perfect square trinomials. Okay, so that's very important to see in that category. So we have plenty of examples to do. So what we do, if a trinomial is a perfect square trinomial, if it can be written so that its first term, okay, is the square of some quantity A, its last term is the square of some quantity B, right? And its middle term is twice the product of the quantities a and b. So in this case, you can write it in this. It's a perfect square. Oh, sorry, I put b. It's supposed to be y. That's square. All right. Now, this is the formula we can use for that, for factoring perfect square trinomials. A square plus 2ab plus b square equal am. So what I mean, for example, if I have x square plus 6x plus 9. Now, look at this one. Do you agree you can write it also x power 2 plus 2 times x times 3 plus 3 power 2? So you understand, if you have something like that, then you can say it's x plus 3 power 2. Remember the 2 times, we said 2 times, right? Now, if the sign in the term of the middle is negative, then you're going to say it's negative. All right, look at this one. The first thing to do to factor it in that format, uh, plus and minus b squared. First of all, I know x squared stay x squared. 2 times what give me 12? It's 2 times 6, okay? Or I can say 2 times x times 6 because I said 2 times the first one times 6. All right, that's give you 12. And 6 squared give you 36. Because of that, I'm going to focus only on these two. So at that point, I'm going to say it's x plus 6 power 2. The plus sign in the middle is dependent on the plus sign of the sign of the b term. If the b term is positive, then it's going to be positive. If the b term is negative, it's going to be negative. Now, let's go with that one. Again, first of all, what term can you write as, is the square of a? So, what you can raise to power 2 to obtain 16x squared? 4x. If you raise 4x to power 2, you're going to obtain 15x squared. Okay. Now, I'm sorry for that, but we missed something from that examples because we have a power 2 here. I need to write it as power 2. I need to fix it. Power 2. I don't know if that changed. No, it doesn't change. You know what? I'm gonna just put power 2. Okay. Let's do power 2. Okay. So there is a power 2 in that term. So what you raise to power 2 to obtain y squared, you raise y to power 2. Now, because the term in the middle right here is negative, we know the next one here would be negative. 2 times the first one by the second one. Would that be give you 16? You see, you have 4x power 2 minus 8 times 2 times 4 is 8xy plus y squared. So we can say that, well, actually, this is for x as the first term, and this is y as the second term. So how to factor this? It's going to be 4x minus y power 2. Right? So we have many techniques how we should be using it. Again, here, our problem, as you can see here, so what do you raise to power 2 to obtain 4m power 4? You said if you raise 2m squared to power 2, you would obtain 4m power 4. And if you raise 1 to power 2, you would obtain 1. Now, let's try the middle. If you do 2 times 2m squared times 1, you imagine that would be 4m squared. So we agree that 2m squared power 2 minus 4m squared plus 1 squared is what we have. We always focus on the first term, the A term, and the B term. So that means if you take only 2m squared and you take 1, you can factor as 2m squared minus 1. Why we put minus again? We put minus is because this term right here is negative. And you say power 2. All right. Um, Something you should understand pretty quick, pretty fine, pretty well. We can continue with exercise 5. Right here again, what you raise to power 2 to obtain 25x squared. I know 5x squared would give us 25x squared. What you raise to power 2 to obtain 9 is 3 squared. Now, remember, it's like AB. If you do 3 square, if you because this one is plus, so we're gonna say plus 2 times 5x times 3. Okay, so that gives you 25x square plus 2 times 5 is 10 times 3 is 15x plus 9. So we agree that's how it's gonna be 5x. Okay, we're gonna have 5x, um, 5x plus 3 power 2. Okay, that's very important. That's how you need to go over this exercise when you have 25x squared plus 50x plus 9. To factor it, you focus on the first term and you focus on the last term. So you said, what should I raise to power to obtain the first term, and what should I raise to power to obtain the last term? So these two terms you find, if you multiply both of them together by 2, so would I obtain the term in the middle? So that's what exactly you're doing. And we can see some other examples here. Remember, what you raise to power to obtain 16x squared is for x. What you obtain to power to obtain, I think that's exactly the same. I think we did that one, right? So it's y squared. Okay, now we know 2 times 4x times y give us 8y squared, so we can factor 4x, y, and in the middle is a negative term. All right, I think we do enough here for you to get it, but how about factoring the difference of two squares? So how are we going to proceed to factor the difference of two squares? So we now factor special types of binomials beginning with the difference of two squared. The special product pattern presented in one of the sections we did previously for the product of a sum on a difference and a difference of two terms is used against here. The emphasis now is factoring. You do factoring rather than multiplying. Look at that. Binomial is the difference of two squares if both terms are equals and the sign of the terms are different. So what we mean, we did that one before. We said if you have A plus B times A minus B, what we said again, one of the section, if I can remember, that was section 5.4. We went over that. So it's going to give you A square minus B square. So both terms are equals. The sign of the terms are different. Now, that's what we did with those type of examples. For example, remember, you can do 3x power 2 minus 5y power 2. So in this case, if you have something like that, this is the techniques you should use to solve it. So any times you have a squared minus b squared, the answer is a plus b times a minus b. If I have x squared minus 9, it's the same thing saying x squared minus 3 squared. Answer would be x plus 3 times x minus 3. X plus 3 times x minus 3. What you just see in the previous examples where we said 9x squared minus 25y squared, we said all you need to do in examples like this is to rewrite it 3x power 2, 5y power 2. Now we can apply these techniques, which is 3x plus 5y times 3x minus 5y. Okay, so those are the techniques you use to factor the difference of two squares. Let's do some examples very quick. One of them would be, this one. Oh, I just did it. I don't know why I already did it. 3 squared, so that gives you x plus 3 times x minus 3. I think I did that one already. But if you go with 7, 1 square would always be equal to 1. 1 power 59 would always be equal to 1. So no matter what exponent is for 1, would be the same. So that means if I do 2x power 2 minus 1 power 2 is the same thing. 1 power 2 is 1. So remember, every time you have a square minus b square, you can factor as a plus b times a minus b. So in this one, it would be 2x minus 1 times 2x plus 1. Multiplication is commutative, either you said 2 times 5 or 5 times 2, it doesn't matter. The answer would always be the same for this. Another examples, even when we deal with fractions, you still can do a square minus b square equal a plus b times a minus b. Now, look at that. You can rewrite this as y square minus 4 over 5 square, right? So answer would be y minus 4 over 5 times y plus 4 over 5. The only thing that make it different with the two terms, one is positive, one is negative. You have the positive sign in the middle for one of them, and you have the negative sign uh, um, in one of them. So that's how we're gonna proceed to have each of them together. Okay? Now, look at that. We said that for this one, you're going to first of all rewrite it so we can show the whole term is power 2 for both of them. Now we can use the technique 6a minus 7b times 6a plus 7b would be our answer. So we can continue like that and we can solve so many different exercises, so many exercises like that. Again, here, this is the biggest problem we can see here. This term in the second, I mean, this x in the second term doesn't have any exponent greater than 1. But you can look and see there is a repeated factor or repeated element. So in this case, the greatest common factor for these two would be x. If I factor x, I have 4x squared left in the first one and 49. Now, if you continue, you can keep your x outside, so you're gonna have 2x power 2 minus 7 power 2. Now, again, when you look into the parentheses, remember when we solve using parentheses, we go first with parentheses, then exponent, then multiplication from left to right, division from left to right, addition and subtraction. Now, this term right there, we can keep our x out. Now, for this term, that's when we're gonna send is 2x plus 7 and 2x minus 7, the best way to factor all these beautiful examples. More examples to see again. 7 power 2 minus x power 2 give you 7 minus x times 7 plus x. It's tricky because you can maybe you might forget and said, "Oh, I'm gonna do x minus 7, x plus 7." So that should be something different. You may be careful. Sometimes some of them may require that we use more techniques. But if I consider the whole thing here power 2, but remember, if we do x plus 1 power 2 and 3 power 2, it still gives me like a square minus b square. So remember, if I have a square minus b square, I do a plus b times a minus b. So here, a for us is the whole thing, x plus 1 plus 3, and x plus 1 minus 3. So if you simplify, it's going to be x plus 4, x minus 2. That will be the final answer. Doesn't mean each time the first squared term would be only a number, just a simple number, or just a simple variable. It can be an expressions raising to power 2. Um, Although the sum of two squares usually cannot be factored, remember you do from what we already did, we said x square, a square minus b square is a square. I mean, sorry, it's a plus b times a minus b, and a square plus b square is prime. It's only a square plus b square. You cannot prime, okay? It's prime. You cannot factor that. That's why we said that although the sum of two squares usually cannot be factored, the sum of two cubes as well as the difference of two cubes can be factored. So that's exactly what we show you here. You know, if you have the sum or the difference of two cubes, you can factor them. So what I would advise you to do is either a cheat sheet or a notepad. You can write those formulas somewhere because you're going to need them. You're going to need them in many circumstances. Let's see these examples. Remember, I said every time you see one can be power anything you want. So if I said one power 3, and we know if you have a cube plus b cube, this one give you the a plus b times a square minus ab plus b square. So that's what we said. So a for us here is x, b is 1. So we're gonna say x plus 1 times x square we don't say 2ab, we said only ab. Now, 1 times x is x plus 1 square is 1. And you see, we do properly well with those examples. Now, let's try another one. We see for this number, they don't raise it to power 3 already. So it's up to you to know what number would you raise to power 3 to obtain 64. So if we have y cubed, we know 4 power 3 is 64. And because it says a cube minus b cube, this is the formula for it. A minus b times a square plus ab plus b square. Okay? We're going to have something like that where it will be y minus 4, no power 2, y square plus ab. I mean, 4 times y is 4y plus b square. I mean, 4 square is 16. I know I go a little bit fast on this one, but you're definitely gonna enjoy it because sometimes there might be a big combinations of so many numbers because 4y cube would be equal to 64y cube. 1 cube would be equal to 1. So if you do 4y plus 1 times 4y power 2 would be 16y square plus, minus AB, okay? So would be, that would be minus AB, that means minus 1 times 4y would be 4y plus 1 square is what? That's one of the examples and how you should proceed to do it. Last examples we can do here, it's no common factor. I like this one as well. There is no common factor. But if you want to see y power 3 and x power 3, y power 3, y2, if you want to see it that way, minus 3z cube. So meaning, if I want to, I can state this one as xy squared power 3 minus 3z power 3. If you agree like that, remember a cube minus b cube equal a minus b times a square plus ab plus b square. Now, reading this clearly would be xy squared minus 3z. First term power 2 now. Xy squared power 2 give us x squared y to the fourth power because we raise it to power 2 plus ab 3z times xy squared. So that means we're going to have 3x y squared z. And 3z power 2 give you 9z squared. I know. I go over this one very quick, factoring some by spatial products. I'm hoping you can use these examples to help you to with the homework and do more and get ready for any tests that are upcoming tests. But in the meantime, enjoy, and I'll come back in a different video for section 5.8, solving equations by factoring and problem solving. Take care. I'll see you in a different video.